Hello, Alex here, and since my initial development shenanigans video I had when Harman Phoenix 200 launched, I have put in a lot of work trying to understand this film at a deeper chemical level. Turns out this film can do so much more than if you just rate it at 200 and develop it in standard C-41. In this video, I want to introduce my project and series, Mastering Harman Phoenix, and show you how to get the most out of this film with standard C-41 color negative development. Let's get into it. As I go through the project, I'm going to be explaining certain topics in a certain amount of detail, and I will give you advance warning if you already are familiar with these topics, so you have a timestamp that you can skip to if, for example, you're already familiar with the chemical nature of pulling versus overexposing, just as one of the topics we're going to go through in this video. Also, because of my nature and background as a PhD chemist, I kind of went through the scientific method with a lot of this. I hypothesize, why is this the case? I figure out a way to test it, I test it, and I share the results. That's kind of how I'm going to go through these stepwise to build up to where I eventually got. Not so much in this video, but definitely in part 2 and 3. So if that doesn't interest you and you find that kind of thing extraordinarily boring, which I totally respect, but that is how I want to present this work to show you the effort that went into it, there will be a conclusion at the end of each video where I will summarize that chapter in a hopefully good enough way. And if you get bored or whatever, you can just skip to the conclusion of each video and see the general gist of what I've done. I'm also not going to do a full introduction for every single one of these videos, so I want to give some background information, thanks and credit before I really dive into it, but you can skip to this timestamp if you want to just get into the C-41 stuff. Although Peter and Maddie from Harman did confirm that the true measured ISO of Harman Phoenix is 125 in the Grainy Days interview, the reason Harman recommends shooting the film at 200 is because the limited dynamic range means that shooting it at 125 on a nice bright sunny day means you will start to lose detail in the highlights, whereas if you underexpose it slightly and rate it at 200, you'll retain that highlight detail at the cost of the shadows, and that was just the recommendation that they made. For that reason, I'm going to be using 200 as my kind of control, my 0 point for this project, rather than 125. I don't own powerful enough flashes, nor could I access them reliably and quickly to actually illuminate my scenes properly for the testing. And I had to shoot at a fairly wide aperture to make sure that even at the highest levels of overexposure, and when stacking filters, I was never getting into reciprocity failure territory, just so my exposure would stay proper, because I don't know the precise reciprocity curve for Harman Phoenix yet. There are a few shots where things are slightly out of focus or they're not super sharp, so don't focus too much on that if you're going to start pixel peeping on screenshots of the already compressed footage, which you shouldn't be doing anyway. I also have a full-time job, and this is just a hobby for me, and I don't live alone, so I was constantly setting up my setup and tearing it down after a few test runs. So like every 3 to 5 runs, there is a complete shift in the position of the lights and everything, and that is something that's like a major limitation of my testing. But because of that and the focusing issues, I decided that I'm just going to do test rolls to demonstrate my points for each major chapter, just to show you some real-world examples where things are actually in focus, weather permitting, shot under good light. For consistency, I use the Bellini chemical kits the whole way through the project, so they're 3-bath C-41 kit and the 6-bath E6 kit. I have a lot of experience with those and I'm very familiar with how they behave, but the most important thing is that I was using the same kits the whole way through. Lastly, I want to give thanks to several people who helped make this project go as smoothly as it has. Firstly, Matt Marash for his help in designing and strategizing how I was actually going to physically do the testing setup downstairs. Next are my friend Kay, a lab tech who's helped me troubleshoot a lot of things, and Peter, my friend and expert on both the RA4 and C-41 reversal processes. These two guys were key to some of the actual breakthroughs in the project, so thank you both so much. Ribsy, Caleb of Bad Flashes, Attic Darkroom, Jason of Grainy Days, Mega Tony Productions in Kowloon, and Silver Halide Studios in Perth, who have all allowed me to use screenshots of their own work or videos for comparisons or just as reference material. The Photoshop.ie, a regular partner of my chemical safety video series, whose rapid shipping was key every time I ran out of film or needed fresh color kits, because with the multiple week-long breaks I was taking at certain points, or just worries about potential contamination or the need to reproduce something and make sure it wasn't just a one-off, I bought a lot of color kits for this project. Similarly, it's quite cheesy, but I want to thank you, the viewers, and my supporters on Patreon for helping soften the financial burden of this project quite a bit. I don't really talk about this kind of thing in my videos, but this project so far has cost me just over 500 euros in film and chemicals, and I would not have been able to justify that if I wasn't having some level of revenue come in from the support. It means so much, and I would not have been able to push myself to actually continue working on this if I didn't have people not so much hassling me and asking why it isn't done, but pushing me and helping and supporting me. So thank you very much. We're already several minutes into the video, but let's get into the actual C-41 results now. To some of you, welcome back. In this video, I want to cover 3 topics. Firstly, why are my negatives so clear and pale when so many people's negatives online are such a strongly tinted purple color? Secondly, what affects the grain more, the level of exposure or the level of development, and how can you play with these to modulate and improve the grain? Thirdly, why is it so grainy for an ISO 200 film to begin with? When I develop Phoenix in the C-41 process, I get very clear pale negatives with a slight lilac tint, but most people online seem to get very strongly purple tinted negatives. Why is that? When I was doing my various test rolls, I had a lot of leaders that I had to clip when I was loading them onto my reels, so I just used those to do a few tests. Whether I used C-41 or E6, bleach, fixer, or both, it didn't seem to make any difference. And there's no washing going on here with these kits. I was just suspending the leaders in a bottle cap, basically, with a little bit of chemical. So it's nothing to do with, you know, like the Ilford purple anti-halation layer you'd see in Delta 100 or anything like that. That isn't used in Phoenix anyway. So what is it? I had a look around and I found that Megatony Productions did some testing online, and they did C-41, C-41 dip and dunk, ECN2 and E6 processing shortly after Phoenix was released, and there's a strong difference in color between the regular C-41 and the dip and dunk rolls. Basically, forgetting about the mechanical process of how dip and dunk works, the core difference here is that for normal C-41 processing, people are going to use their chemicals for a certain number of rolls, chuck them, and mix a fresh batch. With dip and dunk, you're typically mixing a huge batch, using it, allowing it to be weakened by, use of some portion of the chemicals to develop film, and then re-strengthening it with a replenisher. Because you're not completely draining and refilling the tank all of the time, because that would be wasteful, you're going to build up some kind of oxidation byproducts or general crud in the developer. Obviously, this doesn't hamper the development process, and people are able to get perfectly fine scans regardless, but it appears that whatever's in the dip and dunk C-41 cans, whatever's building up over time, either stains the base to a purple color or is unable to remove the purple color if it's already there, and maybe the fresh C-41 bleach and fixer are able to extract that. I can't tell you that for sure. It's fairly anticlimactic, but I guess to the 2 people who messaged me worrying if their labs were doing something wrong, nope. It looks like a spectrum of colors from lilac to deep purple are perfectly normal for C-41 development for Harman Phoenix. So Phoenix is a grainy film, and Harman are very open and forward about this, and you've seen sample pictures, and there's not a lot more that I need to say. In Caleb's video on his channel Bad Flashes, he saw a tremendous difference in shadow detail and grain when shooting at box speed versus when pulling one stop. I want to explain how all this works at a chemical level first, so if you're confident and comfortable with pushing and pulling, skip to that timestamp, but otherwise I want to get into that stuff. I am going to use black and white film as an example because the concept is the exact same for color film, and it just means I don't have to deal with the multi-layered nature of color film, and we're not getting into, the molecular structure of dye couplers or any of that kind of thing today. When you take a photo, photochemical excitation of the crystals of silver halides generates silver nanoparticles, forming the latent image, with more of these latent image crystals formed in areas hit by more light. Developing the exposed film grows those latent crystals by chemical reduction of nearby silver ions onto those seed crystals. If you expose the film to more light when you take the photo, you get more latent image crystals, and if you develop them for the same amount of time as before, you get crystals of roughly the same overall size, so the negative is denser and darker, and after you invert it, darker becomes brighter, giving you a photo that we call overexposed. The opposite is true if you expose the film to less light when taking the picture, generating fewer latent image crystals and then fewer grains after development, giving a thinner, paler negative that gives you a darker, underexposed photograph. Here are 3 photos of Phoenix shot at EI 400, so underexposed one stop, 200 shot at box speed, and 100 overexposed one stop. And here are what those negatives look like. You can physically see the difference in density. Another thing is that films don't just use grains of a single size. Larger grains are more sensitive to light than smaller ones because they have a greater cross-sectional surface area, and films will use a spread of sizes to improve contrast and dynamic range. Putting all of this together, when you expose your film, the larger grains are exposed more easily. So if you underexpose your film, you're going to have a higher proportion of large grains be exposed than if you were to expose normally or overexpose. So when you develop your image, even if you push and do whatever, you're going to have coarser overall grain because most of the grains are quite large. Whereas when you expose the film properly or overexpose it, you expose more of a mix of the large grains and the small grains. So you get a smoother overall appearance to your grain. You're not going to completely annihilate the grain because you can't not expose the big ones if you expose the small ones. You know, the grains are there in the emulsion to begin with before you shot the film. But by exposing them all, you can smooth out the average grain size and bring it down and make the overall appearance look a bit smoother. Of course, you can vary your development too, and not just your exposure. Let's say we take the same photo as before, but 3 times on 3 different rolls of film. One we develop for the normal amount of time, one of them we develop for longer than normal, and that gives those silver crystals more time to grow so they become larger and the final negative is denser and the image is brighter. But this time it's overdeveloped and not overexposed, and the difference there is in the number and the size of those grains. Similarly, developing for less time doesn't give those silver crystals enough time to grow, so they become smaller and you get finer grain but less overall density. And again, this underdeveloped negative will be thin but different to one that was just underexposed. So combining changing your exposure and changing your development together compared to normal development, which we can call +0 or box, pulling is when you overexpose the film and then develop it for less time than normal so you get finer grain, but the greater exposure means you have more of those smaller crystals so your negative doesn't come out thin. On the other hand, you have pushing your film, where you expose the film to less light and then develop longer to allow them to grow to a larger size to make up for the underexposure. And there are other effects on things like contrast, dynamic range, and base fog and the like that I'm not touching on here, but just know grain isn't the only thing affected, but I hope you have a decent understanding now of how all of these things come together to affect the grain in your images. Let's start by looking at normally exposed, overexposed, and then pulled Phoenix so we can see exactly what overexposure does and then what underdeveloping does to actually compensate for the overexposure. Both of the overexposed images have better colors across the spectrum, and I would say having slightly more appealing hues. Zooming into the shadows first, we have much finer grain in both the overexposed and the pulled shots. Underdeveloping didn't seem to help the grain in the shadows of the pulled photo, and if anything it's very slightly worse than in the underexposed photo, but it is still miles better than the box speed normally developed photo, and this does make sense based on what we've seen. Moving on to the highlights, some of you may be expecting what we're about to see. All 3 photos show halation, but there is a lot more halation in the photos that were overexposed. Halation is a glow around highlights and point light sources in your images, usually a red or orange color, and I won't get into how it happens in this video now, but just know that more exposure will always cause more halation in a film where halation is kind of a phenomenon. The halation seems to be reduced slightly by the development, but not back to the same level as the normal photo. So the underdevelopment did desaturate it somewhat, but you can't completely remove it just by pulling your film. Now looking at the very brightest parts of the image, you'll see the highlights in the overexposed image starting to blow out, losing detail in the reflection of my umbrella, but the underdevelopment in the pulled image brings those highlights back down and retains that highlight detail quite a lot better. But why stop at 1 stop? You can pull as many stops as you want if you're willing to manage the shorter development times and deal with the potential risks of uneven development that arise from that. So here's Phoenix at box speed with 2 stops of overexposure and a 2-stop pull. Compared to the normal image, we don't even need to zoom in to see that 2 stops of exposure really blows the highlights out, and there's not a lot of detail actually being captured in the highlights there. The pulled shot is a lot better in the highlights, but they're not completely reined in compared to the box speed shot, and the colors are starting to go wonky with a shift towards magenta and red in the grays, which is probably at least partially from the extreme amounts of exposure causing more and more halation. Looking closer in the shadows, we see the same deal as before with the 1-stop pull. Both images are much less grainy than the control, and the pulled image is slightly grainier than the overexposed one. But aside from changing the time that you develop for, you could also change the temperature that you develop at, and in the world of black and white, that's a perfectly normal thing to do. Standard C-41 chemical development is done at 38 degrees Celsius, or whatever that is in Fahrenheit, and other temperatures do work, just usually not as well, introducing color shifts and other nasty effects, the magnitude of which depends on the temperature you use and the sensitivity of the particular film. Usually people would do it either at 45 degrees for rapid processing or 25 degrees Celsius for lower temperature processing. When the developer adds new silver atoms to a crystal to grow it, they can add to the face of the crystal, the edge, or the corners. Atoms of a crystal are more stable, they're happier, you could say, when they are surrounded by more atoms, of the crystal. So they're happier when they're inside the crystal rather than at the surface. You can broadly generalize this as having more exposed surface area being a bad thing, at least in the context of the Minecraft analogy. The faster addition to the edges and corners is a kinetic process based on speed, and the addition to the faces is a thermodynamic process based on energetic stability. Both of these things always happen all the time, and most chemical or physical chemical processes have a kinetic component and a thermodynamic component. The point is that at lower temperatures, the kinetic variant or path is more favored. It's more likely to happen because there's less thermal energy driving the stability angle. That's all I'll say about that. I think that's a simple enough way to leave it. So what I would expect is that at lower temperatures, you would see increased crystal growth at the edges and corners rather than at the faces. And smaller crystals have a higher proportion of edges and corners relative to their overall volume. So at a lower temperature, I intuitively expect that we would see slightly finer grain by slightly preferential development of the smaller grains in the emulsion versus the larger grains in the emulsion. The negatives are a bit thin, so the comparisons don't work perfectly either, but it doesn't change the actual end result in this case. Comparing the normal shot to the pulled shot, and then using the low temperature photo that was shot at 100 rather than 200 for comparison, we see that the grain is definitely finer in the shadows than the normal photo, but not as fine as in the pulled photo. In the highlights, the low temperature photo is about the same as the normal one with no major difference here, and what also stands out is the extent of the color shifts across the image, with the highlights tinting more green and the reds tinting more orange. The ultra basic version is that on your film base, you have 3 different color layers. You have the red sensitive layer, which generates a cyan dye, the green sensitive layer, which generates a magenta dye, and then the yellow sensitive layer, blue sensitive layer that generates a yellow dye. The C-41 process is a diffusion controlled process that relies on the thermal energy from the temperature to actually drive the developer to diffuse through the porous gelatin through those layers to make sure all 3 of them see even development. When you pour in the developer, it can't actually penetrate through the base, so it hits the yellow forming layer first and has to diffuse through the gelatin to get to the magenta forming and later the cyan forming layers. The specific color shifts that we're seeing here indicate an excessively high amount of the yellow dye being formed in the blue sensitive layer relative to the other 2 layers, which in this case means that at 25 degrees C, the developer is not diffusing and penetrating through the layers of Phoenix properly to get through to the magenta layer and especially the cyan layer, causing these color shifts. Phoenix was designed and made in about a year, which is a tremendously quick turnaround for a color film, especially for your first color film. So massive props once again to Harman for pulling this off at all, never mind doing it as well as they have. Phoenix does lack some standard things we would see with a lot of color negative film, like an anti-halation layer or an orange mask, so it's safe to assume that Phoenix may have omitted other things in the design that may have had some impact on the grain. There are so many components that go into a theoretically perfect color negative film. Like, you think you've got your 3 color layers. Portrait probably has 14 layers and billions of different components, in practical terms compared to us normal people that actually go into making these things work. It is so much more complicated to make a color film than I ever imagined, and I've learned so much about this in recent weeks. So what I want to say is that this part is speculation, and I'm just guessing about a couple of things that I've read about in sufficient detail that might explain why Phoenix is so grainy relative to the box speed of 200 or the true ISO of 125. I have no way to actually test or prove any of these hypotheses or theories. It's just putting some ideas out there to give you an appreciation for how difficult it is to make a color film, I guess, because that's the only way I can spin this part, because I can't actually prove any of it. The question then is, are there components in standard color negative films from the like of Kodak and Fujifilm that restrict and moderate the grain size that Harman may have had to omit to get Phoenix out the door? The answer isn't just yes. Yeah, there are a few types. There are classes of types of things and processes that need to be considered. There's so much going on here. You could have general antifoggants, which act like or stabilizers, which act like restrainers in black and white film that will physically just bind to the silver crystals as they're growing and compete with the developer and reduce the rate of development somewhat. We could be seeing Ostwald ripening, which is the process where smaller crystals get dissolved in the emulsion and the atoms of those smaller crystals get absorbed by the bigger crystals, which makes the overall emulsion more monodisperse, increasing contrast and reducing our effective dynamic range. It could be the absence of something like DIR couplers, DIAR couplers as well. These are a type of coupler which reacts with the oxidized developer like your color dye would, your color dye coupler would. A piece of itself falls off, and the piece that falls off is a strong inhibitor for development, which will bind to the silver and reduce development and potentially reduce contrast, increase dynamic range perhaps, reduce the overall coarseness of the grain and things like that. It could also be various other things like interlayer effects of various types, or the fact that they might be using a single cyan layer rather than a split cyan layer like I think Fujifilm do. They have like a low speed layer and a high speed layer. Again, no way to test any of this. It could be other things like insufficient ballasting of certain couplers causing bleeding, making, you know, maybe the grain actually starts out fine, like we've seen with the pulled rolls, and it actually just gets worse over the course of extended development, not because of the grains growing larger, but because they just kind of bleed and spread out. Again, I can't test any of these things, and unfortunately, that's a bit of a letdown for this part of the video, but I wanted to give you some ideas and some context as to what is going on, because I think the best thing we can take away from that is that if there are so many, you know, dozens of factors going into controlling the grain in a film, and it came out this well to start, I think they did a pretty good job, all things considered. That might not be a satisfactory conclusion to this part to a lot of people, and I appreciate that, but I mean, how am I going to test if something is not in the film if I don't know what I'm looking for? Even if I hadn't an analytical lab at my disposal, you know? So to summarize, if normal C-41 development is all you have available to you, I would try overexposing a little bit from time to time depending on the contrast in your scene. If you're shooting a Miami beach in the bright sunny days, yeah, stick at 200 because overexposing you're going to blow out your highlights. If you're shooting on a cloudy day or in a darker part of the country or just a different season, try rating it at maybe 160, 125 or even down to 100 just to get cleaner shadows, because if you're working in a lower contrast scene, your highlights aren't as bright and you can overexpose them a little bit without starting to lose detail. If you have the option for pull processing either at your lab or at home, oh do it. The difference between standard development and just a one-stop pull with Phoenix is absolutely ridiculous. The film improves so much. A two-stop pull isn't something I would personally recommend, though Kay has done it, I think, twice, 2 rolls, and he absolutely loves the look. So it's definitely going down to your personal taste and the scenes in which you shoot it. At least under my testing conditions, the two-stop pull didn't look good at all. One-stop pull is definitely how I'm going to be shooting this film as a standard for color negative processing for myself going forwards. Low temperature processing is another alternative, but 25 Celsius is not the way to go. We did see finer grain, but not as good as the pull, and the color shifts were just not as good because we're not actually getting sufficient development. I would say maybe like 32 degrees or 35 degrees might be a reasonable option. That's something you're going to have to consider for yourself. The results still weren't as good in terms of grain as just pulling it by a stop, so I would just pull the rolls instead myself personally. So that's all I have to say for part 1 of this project. I'll wrap this video up with some real-world sample images from a test roll that aren't anything particularly exciting, but get the point across just to show you how good pulling looks in real-world images, especially where there's high contrast. I'll see you in the next one, but stay safe, and bye-bye for now. If you don't already, follow me on Instagram at Shaka1277 for new pictures every day. If you liked this video and enjoy what I do on the channel, please consider subscribing or checking out my Patreon, where the tiers start at just €1 per month.